Hi, everybody, and welcome to Backer Breaks It Down. Today, we're going to take a look at slope and lines. So we're going to determine the slope of a line given points on the line or given the graph itself, and then we're also going to write equations of lines. But first, let's talk about slope. Slope, and we use the variable m to represent slope, is the ratio of the vertical change to the horizontal change. Now you may refer to this as rise over run. So when I'm looking at the graph of a function, I can determine what is the rise and the run. Pick two nice points, start on the left, and move to the right. So if you rise up, your slope will be positive, and if you rise down, your slope will be negative, and you're always going to run to the right. So you can use rise over run when you're looking at a graph. Or you can use those 2 points in the slope formula. So the slope formula, we can find that vertical change by subtracting y2 minus y1, and we can find that horizontal change by subtracting x2 minus x1. So over on the right side of the screen, I have an example. I'm given 2 points, -2, -1, and 4, 3. Now, if you have the graph, you can look at the rise and the run. Okay. And so if I want to, I always want to start on the left and move to the point on the right. And so here I'd have to rise up 4 units, and I'd have to run over 6 units. And so I can determine the rise and the run and then simplify the result because it's a ratio. Or I can use my formula, and that's what they're showing here. So they went 3 minus -1 over 4 minus -2, and ultimately they got a slope of 2, 3. Now, horizontal and vertical lines are two very special lines. All horizontal lines have an equation of y equals a number. The reason why this is because when we have a horizontal line, the y values of every single point on that line remain unchanged. So y always equals a specific number. In our example for horizontal lines, y is always equal to -2. Vertical lines have the equation x equals a number. That's because those x coordinates never change. So here we have the equation, the line x equals 3, and notice the x's are always the same. Great. So I can use my slope formula to determine the very special relationships that are happening here. For the vertical lines, they already showed us. They used their slope formula, and they ended up with 2 over 0. Now, we're not allowed to divide by 0 ever, so that's why we say that the slope of a vertical line is undefined. That's the official word. When it comes to horizontal lines, if I were to use my slope formula, I would have y2 minus y1 over x2 minus x1. And I'm going to get 0 over 1. And this is simply 0. So horizontal lines always have a slope that will equal 0. Always. So in these examples here, we want to determine the slope of each line. Well, those first 2 lines, I can use the slope formula, or I can use rise over run, whatever I feel most comfortable doing. So in order to go from n to m, I need to rise up and then run over, and I can simply count to figure out how many. So I'm going up 6 units, and I'm going over 7 units. So that means my slope would be 6 over 7, and it would be positive because I went up and right. Or I can totally use the slope formula, which I'll do for the middle one. So C has the coordinates of -5, +3. D has the coordinates of 4 and -2. So if I use my slope formula, and I have y2 minus y1 divided by x2 minus x1, and I get -5/9 for my slope. And it should be negative because the line is falling from left to right. And then in that last one, that's one of those horizontal lines, and all horizontal lines have a slope that's equal to 0. And so that's how we can find the slope of a line. We can use our slope formula, we can count rise over run, and when it comes to these two very special lines, horizontal lines always have a slope of 0, and vertical lines always have a slope that is undefined. And that's how Becker breaks it down.